To evaluate this integral, we first want to know what the antiderivative is. And then once we have the antiderivative, we can plug in the limits of integration, or we can think about what it would be like if we were able to plug them in. Okay, so the first step for finding the limits of integration, we can let u, first steps for finding the antiderivative. We can make a guess at what u could be, and then we'll see what du is. And if we can replace all the x's with a u and with a du in a way that makes it a simpler integral, then we've done our job. So this is kind of like a guess and check type of thing. What I'm seeing is that this parentheses makes things kind of complicated. So if I could make u be 7 plus x squared, then this parentheses just becomes u. Let's look at what du is to see if that substitution makes sense. Du would be 2x. And we don't have 2x, we have 8x up here, but we could rewrite this integral by factoring out a 4. It's still the same integral. And now we can make our replacements. This becomes du, and this becomes u, and now we're evaluating an integral. And I'm going to make it an indefinite integral because these are with respect to x. U could change some things, okay? In this case, it's going to be u wouldn't change anything because this is always positive. Actually, this is always greater than 7, so that would change the limits of integration. So we'll just evaluate the indefinite integral, and then we'll apply the limits of integration because we have a different variable now. So there's our u squared. This is u. It's being squared, so I wrote u squared here. And another way of writing that integral is you could say that's u to the negative second, because it's u in the denominator. And then I can write du over here. And then to evaluate that antiderivative, we're thinking about kind of the reverse power rule. That's going to be now u to the negative first, but I'm going to multiply that by a negative 1. Because when you're trying to find an antiderivative, you want to think about what's going to happen. These are the limits of integration here. You want to think about what's going to happen as think about what's going to happen when you find the derivative. So if you have negative u to the negative first power, if I was to take a derivative of this, the negative 1 would come down and multiply the negative sign to make a positive 1, so that'd be positive here. And then the power gets reduced by 1. That's the derivative using the power rule. So this is the antiderivative of this, because if I take a derivative of this with respect to u, it becomes u to the negative second. Okay, so now that we have an antiderivative, now we can put it back in terms of x and then evaluate the limits of integration. So there's 7 plus x squared, that's all to the negative first power, or you could write 1 over 7 plus x squared. And then we evaluate that between 0 and infinity for the limits of integration. Probably be easier before we evaluate. Let's put that in fraction form. Same thing. Haven't evaluated the limits of integration yet. I rewrote this to the negative first power, so that means you can put that everything that's being raised to the negative first power in the bottom of a fraction. And now we do the largest limit of integration, the top part first, and think about what happens as x goes to infinity. This gets infinitely large. Plus 7 just makes it a little bit larger. But negative 1 divided by an incredibly huge number, that's infinitely close to 0. So our first result with the limit as x goes to infinity, we get out 0. And you need to subtract what happens when you plug in 0 for x. Negative 1 over 7 plus 0. So negative 1 over 7. Note the two negative signs, right? Because you subtract the two limits of integration, so that's why there's a minus there. And then when we evaluate at 0, we get out negative 1/7. And so when you simplify that, that's a positive 4/7.